When encountering issues with outdoor compact fluorescent lighting fixtures, several problems may arise. These can include bulb length discrepancies, lampholder failures, and ballast failures. It is important to identify the cause of each problem and implement appropriate solutions. Firstly, let's address the issue of bulb length discrepancy. General Electric compact fluorescent triple tube bulbs may be slightly longer than other brands such as Sylvania, Philips, or Cooper. This dimensional difference can prevent the bulb from fitting properly into the fixture. The generic part number for the original bulbs is F26TBX/SBX41/4P. The solution involves checking the bulb dimensions carefully before purchasing replacements. If General Electric bulbs are the only available option, and they are slightly longer, consider bending the lampholder sheet metal slightly to accommodate the longer bulbs. However, exercise caution to avoid damaging the fixture. Secondly, consider the problem of lampholder failure. Poor quality lampholders may be unable to retain wires properly, leading to electrical issues. The solution to this is to identify the problematic lampholder brand. Replace the faulty lampholders with a reputable brand such as Leviton. This will improve the reliability and safety of the fixtures. Thirdly, let's examine the high ballast failure rate in Regent branded fixtures. This can be a significant issue, leading to frequent replacements and increased maintenance costs. One solution is to consider replacing the entire fixture with a more reliable model. This may involve a higher initial investment, but it can save money in the long run by reducing the need for frequent repairs. An alternative solution is to opt for what is considered incandescent fixtures with compact fluorescent refit bulbs. This approach offers several advantages. Firstly, it eliminates the need for specialized lampholders. Secondly, it provides a new ballast with each bulb replacement, ensuring reliability. Thirdly, it utilizes more widely available incandescent fixtures, which are typically more affordable and easier to source. When considering lighting options, remember the importance of energy efficiency and cost-effectiveness. Compact fluorescent bulbs offer energy savings compared to traditional incandescent bulbs. However, if the fixtures and ballasts are prone to failure, the overall cost savings may be diminished. In this case, the alternative solution of using incandescent fixtures with compact fluorescent refit bulbs may be a more viable option. When dealing with electrical work, always prioritize safety. Ensure that the power is turned off before working on any fixtures. If you are not comfortable performing electrical repairs, consult a qualified electrician. Electrical work can be dangerous if not done properly. Regarding specific National Electrical Code, or NEC requirements, always refer to the latest edition of the NEC for guidance. The NEC provides detailed information on wiring methods, overcurrent protection, grounding, and other electrical safety requirements. Ensure that all electrical installations comply with the applicable NEC standards and local codes. When selecting replacement bulbs, consider the color temperature and light output. Color temperature is measured in Kelvin, and it affects the appearance of the light. Lower color temperatures, such as 2700 Kelvin, produce a warm, yellowish light, while higher color temperatures, such as 5000 Kelvin, produce a cool, bluish light. Choose a color temperature that is appropriate for the application. Light output is measured in lumens, and it indicates the brightness of the bulb. Higher lumen values indicate brighter light. Select a bulb with a light output that is sufficient for the area being illuminated. Also, consider the lifespan of the bulb. Longer lifespan bulbs reduce the frequency of replacements and can save money in the long run. When installing compact fluorescent bulbs, handle them with care. Compact fluorescent bulbs contain a small amount of mercury, so it is important to avoid breaking them. If a bulb does break, follow the proper cleanup procedures to minimize exposure to mercury. Contact your local waste management authority for information on how to dispose of compact fluorescent bulbs properly. When working with electrical fixtures, always wear appropriate personal protective equipment, or PPE. This may include safety glasses, gloves, and insulated tools. Protect yourself from electrical shock and other hazards. Properly grounding electrical fixtures is essential for safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker and preventing electrical shock. Ensure that all fixtures are properly grounded in accordance with the NEC requirements. Overcurrent protection is another important safety feature. Circuit breakers and fuses protect electrical circuits from overloads and short circuits. Ensure that the circuit breakers and fuses are properly sized for the circuits they protect. Wiring methods must comply with the NEC requirements. Use the correct type and size of wire for the application. Follow the NEC guidelines for wire terminations, splices, and conduit fill. Regularly inspect electrical fixtures for signs of damage or wear. Replace any damaged or worn components promptly. This will help to prevent electrical hazards and ensure the continued safe operation of the fixtures. When working on outdoor lighting fixtures, consider the effects of weather and environmental conditions. Outdoor fixtures should be weatherproof and resistant to corrosion. Select fixtures that are designed for outdoor use. Consider using photocells or timers to control outdoor lighting fixtures. Photocells automatically turn the lights on at dusk and off at dawn, saving energy. Timers can be programmed to turn the lights on and off at specific times. When replacing ballasts, use ballasts that are compatible with the bulbs being used. Ballasts are designed to provide the correct voltage and current to the bulbs. Using an incompatible ballast can damage the bulb or the ballast. When troubleshooting electrical problems, use a systematic approach. Firstly, identify the problem. Secondly, gather information. Thirdly, analyze the information. Fourthly, develop a solution. Fifthly, implement the solution. Sixthly, verify the solution. When working with electrical circuits, always use a voltmeter to verify that the power is off before touching any wires. A voltmeter measures voltage, which is the electrical potential difference between 2 points. Use a voltmeter to check for voltage on both sides of the circuit breaker. An ammeter measures current, which is the flow of electrical charge. An ammeter can be used to measure the current flowing through a circuit. This can help to identify overloaded circuits. An ohmmeter measures resistance, which is the opposition to the flow of electrical charge. An ohmmeter can be used to check for continuity in a circuit. This can help to identify open circuits. When working with electrical tools, always use tools that are in good condition. Damaged or worn tools can be dangerous. Inspect tools regularly for signs of damage or wear. Store electrical tools in a safe and dry place. This will help to prevent damage and corrosion. Keep electrical tools clean and free from dirt and debris. This will help to ensure that they function properly. When using electrical tape, use a high-quality tape that is designed for electrical applications. Electrical tape is used to insulate wires and prevent electrical shock. When making wire connections, use the correct type of wire connectors. Wire connectors are used to join wires together securely. When running wires through conduit, use a wire puller to make the job easier. A wire puller is a tool that is used to pull wires through conduit. When bending conduit, use a conduit bender to create smooth and accurate bends. A conduit bender is a tool that is used to bend conduit. When cutting conduit, use a conduit cutter to make clean and precise cuts. A conduit cutter is a tool that is used to cut conduit. When threading conduit, use a pipe threader to create threads on the ends of the conduit. A pipe threader is a tool that is used to thread conduit. When installing grounding electrodes, use a ground rod driver to drive the ground rod into the ground. A ground rod driver is a tool that is used to drive ground rods into the ground. When testing ground resistance, use a ground resistance tester to measure the resistance of the grounding system. A ground resistance tester is a tool that is used to measure ground resistance. When installing surge protectors, use surge protectors that are rated for the voltage and current of the circuit. Surge protectors protect electrical equipment from voltage surges. When installing arc fault circuit interrupters, or size, use of size that are rated for the circuit. A size protect electrical circuits from arc faults, which can cause fires. When installing ground fault circuit interrupters, or GFCIs, use GFCIs that are rated for the circuit. GFCIs protect people from electrical shock. When working with electricity, always be aware of the potential hazards. Electricity can be dangerous if not handled properly. Take the time to learn about electrical safety. This will help to prevent accidents and injuries. If you are not comfortable working with electricity, consult a qualified electrician. A qualified electrician has the training and experience to perform electrical work safely. Remember, electrical safety is not something to take lightly. Always follow the proper safety procedures when working with electricity. Adhering to these guidelines will help ensure safe and efficient compact fluorescent lighting system operation. Always consult local electrical codes and a qualified electrician when necessary.